Okay, lesson 2 continuing further still. I'm looking at page 13. We're going to kind of put an end to this f prime of a before we move on to another concept. Okay, on this we're talking about special consideration endpoints. What this is saying is, let's say I have a left endpoint to a function, and my function looks like this. Well, I cannot get f prime of a from the right to equal f prime of a from the left, assuming, of course, that this is x equals a. I can't get that because there is nothing over here. And because there is nothing over here, we don't want to say that this point doesn't have a slope. We don't want to say that the derivative doesn't exist at this point here. So mathematicians have decided that endpoints are going to get special considerations. So in this case here, we say that f prime from the right of a exists, and because that respective one-sided derivative exists, we say therefore f is differentiable at left endpoint x equals a. The same can be said about a right endpoint. Let's say a right endpoint has a value at b and looks like this. We would say from that f prime from the left of b exists, and because that respective one-sided derivative exists, we would say f is differentiable at right endpoint x equals b. So before moving on in this lesson 2, it's important that we solidify at x equals a what are things we have talked about in this first unit. We've talked about, does there exist a limit as x approaches a of some function f of x? That can be explored. We can also ask, is the function continuous at x equals a? We could also ask, is the function f of x differentiable at x equals a? So I want to solidify this at x equals a before moving on to something else called f prime of x. Different concept than f prime at a.